Problem 3 gives us Sven walking south at 5 feet per second from a point 120 feet north of an intersection. At the same time, Rudyard is walking east at 4 feet per second from a point 150 feet west of the intersection. The first part asks us to write an expression for the distance between Sven and Rudyard t seconds after they start walking. So I first started by plotting their points with using the intersection as 0, 0. I Sven up here at t equals 0 at 0, 120, and Rudyard over here at t equals 0 at negative 150, 0. Then I went ahead and made parametric equations for them. So for Sven, since he's traveling along the x-axis, his is just going to stay 0, but his y is going to change starting at 120, and it's going to decrease by 5 times t, because 5 is his rate. And Rudyard did the same thing, except for him, he's traveling along the x-axis, so the y is going to be equal to 0, and then his x is going to be negative 150 plus 4t. Then I just need to find the distance. So if you make a triangle here, the distance is going to be the base value, and then the height value, and then use the Pythagorean theorem to find the distance between them. So that's going to be basically the x points of them minus each other squared, plus the y's minus each other squared, and the square root of all that. Or since the x value and the y value aren't changing, we can just use the base as the equation for x for Rudyard, and then the height as the equation for y for Sven, and then use that for our Pythagorean theorem. And I plugged those in, and I just got the square root of negative 150 plus 4t squared plus 120 minus 5t squared. Plugged everything in and simplified to 41t squared minus 2400t plus 36,900. Then to find the minimum, we know that it's going to be a positive parabola because we have a positive value here and it's squared. So we can just find the vertex to find the minimum, and so I used negative b over 2a to get 2400 over 2 times 41, which simplifies to 1200 over 41, which just equals about 29.3. So we know that they're closest at 29.3 seconds, and then to find the distance between them, we plug 29.3 into our Pythagorean theorem equation, and then we get negative 150 plus 4 times 29.3 squared, plus 120 minus 5 times 29.3 squared. I got these values for each one, and then just put them into the calculator like this, and we get 42.17. So they're closest at t equals 29.3 seconds, and the distance between them at that time is 42.17 feet.